Following Mr. Huang, please welcome Mr. Costello, Product Development Coach from Rector, to talk about agility in the cloud era. Please welcome him with a round of applause.
You have the medication here? So the topic is agility in the cloud, or in the cloud era. Some speakers earlier have talked more about the big data aspect, massive scale, and so forth. So that's good because I want to focus on more personal scale, as a programmer, as an application developer. How can you use the modern technologies of today to work in a more agile manner? So let's start by declaring what we mean by agility. So there are agile software development methods. I'm not talking about any specific method as such. I'm talking about the general ability to move faster than your environment. So when I'm talking about being agile or achieving agility in the cloud era, I'm talking about ways or techniques, technologies, tools that help you get feedback faster so that you can maneuver earlier, so that you can learn faster, so that you have information earlier. So we're going to run through a few of these technologies, and I only have half an hour, so it's going to be fast-paced. I hope you can follow. First, I'd like to point out that cross-platform development is one of the big challenges here. It's not just that we have sometimes massive scale in terms of users. As a programmer, depending a bit on what I'm trying to do and who I'm going to target, I might have to deal with a massive set of platforms to worry about. So luckily we have technologies like HTML and so forth. JavaScript, it's a decent language. And we have frameworks like Sencha Touch and a bunch of others that help make it somewhat easier to build applications, proper applications with a decent architectural structure inside using these web technologies. So those things exist. They're not really cloud technologies as such, but some more cloud-centric technologies that you might want to consider when you talk about cross-platform development are tools like Xamarin Test Cloud. So they're not the only one, but there are these services that you can basically outsource to. So you have an application you're developing with, let's say, HTML and JavaScript, and you want to test it on 10 different devices. You might not even have access to those 5 devices yourself, let alone trying to figure out how to install the application, deploy the application to every one of those devices, run some automated tests, and get some kind of sensible reporting backs, being able to tell whether everything works as it should. So tools like this test cloud here, they let you tell which platforms to target. They'll run those tests in parallel, and they'll provide you the feedback. Similarly, it can be difficult to get feedback from a wider audience. Let's say the help desk people or friendly users. This Flight app might help. They basically make it easier to distribute pre-release versions to your testers or users. So that's about everything I want to say about cross-platform stuff specifically. Instead, I'd like to talk in a bit more generic manner. And the structure I'm going to use is what I think is the main sort of drags on a project. So if you think about a project, let's say a cloud-backed mobile app, so to catch all the sort of corners of the cloud era, where does the time go? I think there's 4 main sources. There's a big and significant effort of figuring out what is it that we can build. I might have a great idea, but I also need to find a way to validate it before I run out of money and mortgage loan starts scaring me too much. So that's one big thing. Then we have to actually build the application. We need to figure out how to test it, possibly on a bunch of different devices. And we need to deploy it. Depending a bit on the scale, it could be trouble. So let's start by figuring out what to build. There's this general idea it's not new. Designers have worked in an interactive manner for ages. It might not be that recent that designers in general have been able to articulate what their process is. But I'm pretty sure that whoever first picked up a pen and paper and figured out that they can draw, I'm pretty sure they very intuitively started to iterate. So in general, when let's say you're designing a mobile app, you have an idea, you've done some user research, maybe you just ask two of your best friends what you think of this idea. But anyway, you have an idea of what the problem is you're going to solve. Now you're trying to design a solution that will solve the problem. That design would be one activity here. Next, you need to figure out if it actually works. So you make up some kind of prototype. It might be a paper sketch or something like that. It might be a paper prototype made out of slips of paper. It could be really hi-fi in a sense, or it could be digital. You can make very high fidelity prototypes as well. And once you get that prototype in place, you can test it. You can test the solution, simulate through scenarios, and figure out if your solution actually supports the kind of goals that your users have. So this process isn't new, but what the cloud era has provided is a bunch of tools, because cool new technologies are coming out. So people are building tools for those technologies, and the sort of convergence of mobile application development being so popular. We have tools like Balsamiq, for example, which make it fairly easy to make digital prototypes. Now, how this relates to sort of internet people being distributed, for example, is that digital prototypes enable you to simulate or test your prototype with people who are not in the room. You can actually send the prototype, a clickable prototype, to somebody else and observe what they're doing with it. So you might create these sort of mid-fidelity prototypes, might help you work faster, get faster feedback, and so forth. I'm going to skip over the middle two ones for now. We'll come back to building the application. Testing the application, I'm going to skip altogether. There are these cross-platform services. I hope that's not if you want to hear more, talk to me afterwards. But deploying that, there's a couple key services or key classes of services that I think everybody should at least evaluate. The examples here are Amazon Web Services, for example, so just infrastructure. And then there are platforms like Heroku, which essentially build on top of services like Amazon Web Services. So the infrastructure, sure, it scales up on demand and so forth. That's one aspect. We'll come back to that. But Heroku or services like Heroku, they can help you work faster as an individual programmer sitting at the office amongst other programmers. Because the trouble of figuring out where I need a new installation, I want to test some stuff. I have a big architectural change in mind, and I can't mess up with the shared environments or something. And it might take days or even weeks to get an environment from the IT group. So services like Heroku make it even easier. You don't have to get an Amazon image and then configure it yourself. If you're using one of the supported technologies, you simply tell Heroku that I need a computer, I want to run this Ruby on Rails app on it. And it's 1 minute overhead the first time you do it. And the second time, when you update, you republish, you're talking about seconds. So these services are clearly something you should be looking at. But I'd like to point out something that might not be so obvious. It kind of already borders on building the application. It's about using Amazon and services like that for personal productivity gain. So I'm going to show you a couple of video clips running in parallel. So it's a build script that a programmer would run locally. So this goes back to a few years ago, 2009 I think. I was working on a project and running the whole build, so compiling everything, running a bunch of automated tests, like 17,000 of them or so. It took 24 minutes. So 24 minutes is enough that nobody's going to run it every time they make a change, which caused a lot of problems, of course. But it also, during those 24 minutes, the laptop was completely bugged out, so you couldn't do anything else. You couldn't edit code while the build was running. So one of my coworkers started playing around with the idea that maybe you can get a higher powered computer. And we can't get expensive hardware. What if we lease computing power from Amazon? So he set up this first draft of the script that would upload your working copy to a server, run the build over there, and just feed back all the logs. So when we did that, it proved out to be a good idea. And I just recorded a smaller sample project running the same build, the same code, on a local laptop, and the same build running the exact same configuration, but it's delegated to Amazon. So on the right-hand side, you can see that it's already running tests. On the left-hand side, well, you can't see. But on the left-hand side, it's still, gathering resources, copying resources from one folder to the next. And whoa, it's the local build is starting to run tests. That's good. Let's see who's going to finish first. Oh, the Amazon build. So in this case, the Amazon computer, which you just say, I think that's only a 4-core computer, like 8 computing units in terms of Amazon's. I'm not sure what it actually means, but it's supposedly higher power than my laptop. The Amazon build took 1 minute, and the local build, which I didn't want to show you fully because it took almost 4 minutes. That's almost 4 times as long. And on our project with 24-minute builds, just by doing an rsync over to the server and then triggering the build over there, that got the build down from 24 minutes to less than 4. So that's more than a 6-fold improvement. And it costs something like 10 euros per day. We're a Finnish company, so think in euros. So it's clearly worth it. So that's something that I think still needs better tooling. It's not difficult to do this manually or put these scripts together yourself. But I think there's a place for productization. So if you're thinking of a new startup, that might be one. But there are other things about building the applications where we can use modern technologies. I'd like to focus specifically on iOS. Can I have a show of hands who's working on iOS applications? Anyone? There's a few people. Are you working on native applications for iOS? Meaning writing Objective-C, right? A couple of hands. I saw one person volunteered by somebody else. I'm not sure if they know they're doing iOS development, but somebody else thinks they are. So I tried that, and I'm not an Objective-C guy. I'm more of a Ruby guy. So when I started looking into Objective-C the first time, I could see these very familiar things. And all I could think of was, oh, that's a bit like 20th century, right? Yeah, like what's the thing with header files? If I need to add a field to an object, I need to do it in 2 places. So aside from the syntax being a bit more verbose, there were these small things that just kept bothering me. So luckily there are people, Lawrence Lanzanetti originally from Apple, while at Apple, he basically wrote this tool chain that lets you write Ruby code, Ruby source code, and it compiles into native instructions for the Mac platforms. So Ruby Motion is an evolution over that, and it's essentially a tool chain for doing native iOS development using Ruby as the sort of programming language. So, for example, the stuff that you saw a couple of slides earlier, in Ruby Motion, it would look like this. It's a fairly big difference. So, I'd like to show a couple of things. So I'll switch over to here. So, one of the most important things in Ruby Motion is that it's a command line based workflow. So it's, oh okay. I had a nice little clean copy of my stuff. There. And I didn't even have to show you my travel history. So it's a command line based workflow, and everything is, the only thing you need Xcode for is essentially to make a certificate request to Apple so you can get a distribution license. Everything else you can stick to VI or Emacs if you want to. I won't, but you could. So the process essentially is you edit and then you build. You use standard Ruby tools like rake. It gathers all the code, the resources, it compiles everything. If you have automated tests, you can run them. And it produces a native binary that you can run in the simulator like what I'm doing here. Or you can put it for in-house distribution. You first have to sign it, but anyway. So the outcome is literally native application. You can't see the difference between an Objective-C originated application or a Ruby Motion originated application without looking at the bytecode symbols. Maybe you can see that there's some naming convention because yes, they generate code underneath, but it looks native. So, for example, if you've done HTML apps, you've probably wondered how to get the tabs work as smoothly as a native app, or look the same, or the scrolling as smooth as the native version, and so forth. With these kinds of technologies, that's not an issue. Also, there's a couple other things. So if we, for example, look at the code, we're actually using the native API. It's not like we're learning a proprietary API that wraps the real Apple-provided APIs. We directly use the native classes. So for, let's take the map controller here. We use an MK map view, which is the real thing. And we call methods like alloc init, which I hate. But that's what the Objective-C guys would do, right? So you can actually work or get over it. You could say, instead of that, you could say nk map view new. That would work in most cases. But in general, the Ruby motion community tends to think that it's generally good practice to use the APIs in a similar manner as the Objective-C people would do. It makes it easier to translate back and forth if you need to for some reason. So that's one thing. You can also mix things. So you can mix native Objective-C code and Ruby code. So for example, CocoaPods, which is a great tool for Objective-C development as well. In Ruby motion, you simply declare dependencies to a certain CocoaPod, certain version, and then you run the build, and Ruby motion, the tool chain will take care of grabbing those sources, compiling it, putting it into your sort of, or linking it into your application, and then you can use it just like any other code. So that's also useful. Also, I said that the Ruby motion, you have Ruby language to work with. It's not entirely true, so not the full language is available. For example, you can't see any requirement statements. The differences are fairly small. So for example, we could, if we see some kind of boilerplate, let's say the list controller, we have this kind of a thing. We want to assign a data source and all kinds of delegates. And if you have several table view controllers, probably every one of them is doing the exact same thing. So you can use, for example, Ruby modules to sort of get rid of that duplication. So you create a module like that, and then you include it wherever you want them, and that will work just the same. You can use the Objective-C native, the real APIs if you want to, but you can also use Ruby gems. So most of the Ruby gems out there, you can use within Ruby motion apps. If they do some native compilation within the gem, that might not work. Many of those will also work, but they might not. But there's a lot of options to mix and match here. And the outcome is something fairly native. So let me go back to the slideshow here. I showed you very quickly a number of these technologies. This is not a comprehensive list. Xamarin, the company doing this cloud cross-platform testing service, they also have tools, can't remember the name, but they also have a tool where you can write .NET code and compile that into native applications both for iOS and for Android. And a bunch of other services, technologies that I might not even know. So I'd like to close with this thought that I want to leave you with. New technologies are born all the time, right? But none of those new technologies are useful unless they remove a real existing bottleneck, some kind of a constraint of the past, right? So when we're talking about what we can do, what technology enables us to do, we fairly naturally think about, oh, great, so now I can do this. But we should also think about what can we stop doing. So for example, a lot of companies do annual budgeting. And the reason boils down to 100 years ago, we had a constraint. The only way to know how much money we had in the coffin was to close the shop and count the coins by hand, or go through the warehouse and count the number of chocolate bars and bread and whatever. Then you would know how much money you have, how much inventory you have, and then you could make budgeting decisions. You wouldn't want to do that every day, so you just said, well, let's do it once a year. Now, the bottleneck of not knowing what you have, that's long gone. But still, many companies are doing annual budgeting. Now, in technology as well, we've adopted a bunch of technologies, we've created a bunch of technologies, but I'm suggesting that we might not have thought enough about what can we get rid of with all these new technologies that are out. So sometimes the new technology itself makes you most productive, but it could be that it's actually something that you can stop doing that makes you even more productive than that. So I'd like you to keep an open mind with technologies, experiment, prototype with the ideas, and use all of these nice technologies. That's what I want you to do. Thank you.
Thank you, Mr. Koskawa.